that's going to change, right? But in this case, if given that I got a club, the probability of king didn't change, did it? So if the probability of A given B doesn't change, A doesn't care that B happened, whatever. That's obviously going to be independent. That's like that 1/13th and 1/13th. A king by itself, or a king given that it's a club. It didn't care that it was a club. Still the same probability, right? If this is true, then they're independent. So remember this. We got this the other day. So that's that. That's the test for independence. Recall probability of A and B. We did this the other day. If you guys remember that. And all we did was we took the given probability we solved for the and. Right, that's what we did the other day. If B and A are independent, which part of this changes?
B.
What's probably B given A if A and B are independent? If they're independent, will A change the probability of B?
No.
No, if they're independent, it shouldn't change, right?
Yeah.
So in the case that they're independent, the probability of A and B is probably A times probability of B. Because that one won't care, right? A happens, who gives a shit? So over here, why did that not change? It's the same as what the king was before because I put the first card back in. Why did this one change? Because I didn't put the first card back in. So of course the probability changes, right? Maybe. I'm always hopeful. Okay, so one last piece we're missing, and then we can do just about every probability problem that we're going to get in this section. And that's just what to do if you have a huge population. So, for example, so here with a deck of cards, would you say my population is really large?
No.
It's only 52, right? So isn't 4 out of 52 very different from 3 out of 51? You guys help me out. What is 4 divided by 52? It's like 7 something. What is that?
0.0769.
All right. What's 3 divided by 51?
0.0588.
Say again, sir.
0.0588.
Those are pretty different. Those are pretty different. I don't know if you agree with me, but I'm telling you now, they are different. Right? Definitely. Because I have a small population, right? Okay, you with me on that? Now, what if I have 50,000 people and 1,000 of them are crazy? Right? It's probably low. What's the probability I pick a crazy person?
1 out of 50,000. 1 out of 50,000.
1,000 divided by 50,000, right? What's the probability now? So what would that be? That'll be band, so 2%, right? What if I took a person and they're crazy? So I put them obviously in a little room, probably rubber and straight. What's probably I pick another crazy person then? So it's probably I pick a second crazy person.
Take away.
Just like we did before with the 3 out of 51, won't it now be 999 out of 49,999? What's that? Somebody do that for me. That was not quite as easy, but it's going to be just about 2%.
0.0199.
What is it?
0.019988.
Isn't that freaking 2%? Basically, right?
Yes.
So here's the nice thing. Let me give you a problem that shows you what I'm talking about here. You only have to worry when your population is very small. When the population you're dealing with is really small, you'll have to do it like this. You'll have to actually show what the next probability changes to. Here's where this becomes really handy for us. Most of the time we'll be dealing with large populations. And I think I asked this before, out of my own curiosity, how many of you guys were left-handed again? Anybody left-handed? Hey. Alright. And that's less than I would expect, because 11% of the population roughly is left-handed.
17.
17 now? I haven't checked in a few years. Is it up to 17?
I got it. Yep.
Well, of course it should have went to you. You're my left-hander. You would know. So let's say that the probability of being left-handed is 17%. Wow, I got it. That's cool. I didn't know it jumped up that much. Now, how big of a population are we talking about? Well, right now I'm talking about the U.S. actually. World statistics. Oh, is that for the world?
I think so.
Really?
That's what I've heard.
All right, let's go with it. I'm gonna double check that, but let's go with it. So let's say that's the whole world. So now we're talking about freaking 7 billion people, whatever, 6 point whatever it is, only 7 billion people, right? Could you imagine first doing 17% of 7 billion, see how many left-handers there were, and then changing it to be 6,999,999,999. So thank God, if I pick 5 people from the world at random, so I just spin a globe and I got tons of money, so I just fly out there and say, you left-handed or right-handed? Right? And they say ambidextrous, and then I like, get away from me. You guys know ambidextrous? Yeah, I'd give my left hand to be ambidextrous, but I'm not. So you pick 5 people at random for the world, and I want to know the probability that all 5 are right-handed. So let's say, you can't say ambidextrous, you have to say one or the other. Normally we have a hand that we like to use more, even if we can use both pretty well. So this is what I meant earlier. I've got 5 people I'm thinking, right? There it is. So I want 5 spots. I like to think of it like my hangman game, right? I've got 5 spots. This one and this one and this one and this one and this one. Now what do I want this first one to be?
6 billion something.
Now see, this is the nice thing. I don't have to do that now, do I? And what I want you to understand is that the rule is, if the sample you're picking is less than 5% of your population, then you do not have to do this kind of thing. Thank God. And 5 people is definitely less than 5% of nearly 7 billion, right? So most of the problems we work with in this class, the population is going to be large enough to not have to worry about adjusting every step here, right? So what do I want this first person to be? Right-handed. So what probability do I put here? There's a 100% chance they're right-handed?
No.
What's probably the
There's a
first person is right-handed?
50% chance.
Say again?
50%.
No,
83%. Where'd that come from? 17% chance they're left-handed, so what's probably the right-handed? 83%. Right? How we doing?
all of them.
And I want this guy to be right-handed. 83. Right? And this guy, and this guy, and this guy. Mathematically, does anybody see a shortcut for that? How many .83s do you have? 5. So isn't that just .83 to the 5th power? And what is that? Somebody help me out.
0.3939.
Okay, sure. About 39%. Okay. So what I want you to see is, what did we do the other day? Recall. I'm doing a lot of recalling today. Probably king and then a king. Didn't we do 4 out of 52 times 3 out of 51 when I was doing it without replacement, right? These aren't decimals, but they're the same basic thing here. I could make that into a decimal, couldn't I? 4 divided by 52, I could plug a decimal in there. So it's a probability that I got this, and times the probability that I got this end, right? It's exactly what we're doing. The probability I get the first person's right-handed, and times second person right-handed, and But I don't have to do this because the population is so big, it's not going to change by enough, anywhere near enough to worry about it. You guys get the feel for that? Okay? You guys, I don't want to play poker with you. You got this. Don't need to wear glasses. You can't. All right. Because here's something people make a mistake. I see somebody do this kind of thing all the time. Can you see the mistake this person made?
Yeah.
He's saying that how many people in the world? 100. That's neat, right? That would make a lot more room. Probably wouldn't run into anybody else. I don't know. What I really want you to get is, why am I multiplying here in the middle? Because if I want 5 right-handed, I want the first guy to be right-handed, and so forth, right? That's why I know to multiply, right? How do I know I don't have to change these numbers? Because the population is large enough. I don't have to worry about changing them. So are they independent? If I pick one right-hander and I put them aside, are they really independent? No. Can I treat them as if they're independent? Hell yeah, man. This will go down to like 0.82999999999. Okay, that's freaking 0.83. Leave me alone. Do you see what I'm saying? Okay, let's do another problem, because these are actually going to become stupid important really soon. We're going to build off of this idea. So, let's see. I forgot to look up like a real data point. Let's do that. Let's say that 21% of Americans enjoy liver.
Yum.
All right, let's get it all ours. If I pick 7 people at random, right? What's the probability that the first person likes liver and the rest don't? Here's a really cool thing about this hangman game. You have control, don't you? So how many spots do I want to make? 7. This one and this one and this one and this one. I have to do 7. This one and this one. And I've lost count. 1, 2, 3, 4, 5, 6, 7. Again. So now I've got to do, is there a large enough population?
Yes.
Yeah, 310 million in the U.S. roughly. I don't know where it is right now. But, and I'm only thinking 7 people. I think that's less than 5%. Right? So what do I put here? What do I want the first person to do?
21%.
Yeah, I want them to like liver, so I want them to be 21% probability of getting somebody who does what I want them to do. And then the rest of these are going to be 79. So what's a quicker way to write that? 0.21 times 0.79 to the 6. Does everybody see that? That's where your algebra sort of comes in here. All right, these are all going to be 0.79, and you got 6 of them multiplying. Isn't that why exponents were invented? So I didn't have to write them all out, right? They were invented because math people were lazy. I want to write 6 of them. I just want to put the number 6. Yay. So what is that? Somebody help me out. Do you all know how to do 2 to the 6th power in your calculator?
Yeah.
If you have a TI, it should be this button. If you have a scientific calculator, for some reason you got this button. So what do you get? 0.05. 1. Okay, so like 5%. I love it. Cool. All right. So, bless you. I think we are armed with enough information now to do this little practice quiz. So on one side there are the problems, on the other side there are the answers. So don't look on this side yet. Agreeing with me is not going to help you.